For other typhoons, some of them may reduce its translation speed before or during landfall. For example, this one. However, none of them is as commonly slow as Morakot. I also plot this figure. I calculate the speed ratio to see the speed change before, during, and after landfall. You can see for Morakot is this one. Its ratio dropped to 0.7 and then 0.4 and then 0.3, which is really unique. Okay, now I also checked the average southwesterly flow and rainfall average inside this small area to the southwest of Taiwan. And you can see the average wind direction of Morakot is about southwesterly. And the average wind speed is 21.5 meters per second, which is the largest among the 19 cases. And not surprisingly, rainfall is also the largest, you can see. And also you can see that this diagram here is much clear to see the comparison between the 19 typhoons. And you can see Typhoon Haitang has the second largest average wind and wind speed and rainfall. However, because the translation speed of Typhoon Haitang is not as slow as Morakot, therefore it is accumulated rainfall over land is not that heavy as Morakot. Next, I want to show the composite of these 19 typhoons, which is shown in the upper left. In the upper right, it is for Morakot, and this is the difference between the Morakot and the composite. At 24 hours before landfall, the composite typhoon is located right here, and it is moving westward because of strong steering flow provided by the Pacific High. However, for Morakot, it is located right here, and near Hong Kong, there is another typhoon called Goni. We heard that yesterday. And the Pacific High is extending northwestward instead of westward in the composite. And the difference shows that relative low pressure occupies the Western Pacific at this time. And that's why Morakot starts to reduce its translation speed by this time, because the steering flow is very weak. Okay. Now this is the landfall time. At landfall time, the pressure pattern is quite similar to the previous one. In addition, there is another typhoon called Atoll forming to the east of Morakot this time. And the difference shows that the low pressure systems are surrounding Morakot. And 24 hours after landfall, you can see the most typhoons have moved over land over the southeast of China. However, Morakot is still hanging around here. 48 hours after landfall, there was a trough moving to the northeast of China, and another trough located in the east of Japan, and the Pacific High is in between. And there was a strong southwesterly flow associated with moisture conveyor belt that extend from East Bay of Bengal to the Taiwan area. Okay, next I want to talk about the world model simulation of Morakot. First, I want to acknowledge the contributors of this part of work, Xie Zhangmei and Zhang Yangchen, who are my research assistants. And from this figure, you can see the world model did a very good job in simulating in the Morakot trade. This is the 24-hour rainfall. On day one, most areas in southern Taiwan received rainfall exceeding 300 millimeters, and the maximum is about 800 millimeters. On day two, rainfall increases rapidly, and the maximum rainfall exceeds 1,000 millimeters. In the simulation, the maximum rainfall is about 700 millimeters, which is not bad. However, the location shift a little bit to the north, to the south of the observation, because the simulated track is located about a little bit to the south of the observation. And on day two, the maximum rainfall, the location of the maximum rainfall agreed well with the observation. But large rainfall mostly occur in the mountain area. This is what Professor Chien was talking about. And the rainfall over the plain area is smaller than the observation. And 24-hour cumulative rainfall shows that the observation is over 2,000 something, and in the simulation is about 1,800 millimeter. Okay, now at the 24 hours, Morakot is located somewhere here, and there was strong convection in the south. And the world model actually reproduced very well the strong convection in the south. I'll go faster. I think I'll skip this one. Okay, at 36 hours, there was a strong southwesterly flow that moved over land and produced strong convection and large rainfall over the mountain. Now this is at the 29 hour, we make backward and forward trajectories and also make a cross section along this line here. You can see air parcels that air parcel near the convective line here comes from two different air sources. The first is from the northwesterly, the second is from the southwesterly. And the convergence here produce many MCS that move over land, resulting in heavy rainfall there. And I also further checked the property of the air parcels. Number 2 is from the southwest. It has the largest and highest temperature and largest water vapor mixing ratio. And number 10 is from the west. And numbers 4 and 8 is from the northwest, which is a part of Typhoon circulation. And they are a little bit cooler and drier than number 2 air parcel. In other words, the southwesterly flow is warm and moist. And when it converges with the westerly and northwesterly, it produces a strong convection there. Now this is the last slide. Okay? This which shows the time evolution of maxima BBZ from south to north along these 3 lines here. On day 1, you can see there was a large BBZ in the south, which is caused by the typhoon circulation. Because during this time, Morakot is making landfall and move northwestward slowly. And you can see the large convection first move southward quickly and then move northward slowly over time. And on day 2, you can see the convection, actually the convection was primarily caused by the convergence between the southwesterly flow and the typhoon circulation. Therefore, you can see the convection becomes stronger and stronger when it moves over land and over the mountain. And also the convection here is kind of hanging around in this region because it first goes to northward and then southward. And the temperature shown here, this is the same as Professor Taichi showed earlier. Okay, summary. I think I'm running out of time. I'll just leave it here for you to read. Thank you.